Hello everyone, my name is Emanuele Giuseppe Esposito and I'm a software engineer at Red Hat. Today I'm going to show you a demo where I run an AI workload on Azure OpenShift self-managed cluster. The AI workload runs on the confidential computing virtual machine. For this demo, the confidential computing VM also utilizes the Intel TDX technology. Let's first look at the architecture. We have the OpenShift data science operator provided by Red Hat that provides a very nice interface and infrastructure for the data scientists to upload AI models and run them on OpenShift platforms. On the other side, this model is accessible by the user using gRPC requests. In this case, the model is an LLM. In order to run an AI workload securely with additional security, we want to use the confidential computing VMs. This enables additional security because it protects the data that is the user data that is inside the AI model even from the host where the VM is running. The confidential computing VM is provided by the Red Hat OpenShift sandbox containers. This operator provides the PeerPods technology, also known as Kata Remote Hypervisor. This technology allows us to run a VM on the public cloud without using nested virtualization. What this means is that a pod will run inside a separate VM, inside, for example, Azure, and it will be visible from OpenShift as a normal pod, as if it was running in the worker node. This VM can be then extended to run as a confidential computing VM, providing an even additional layer of security, in addition to the traditional VMs. So let's first look at the architecture. So we can see from the Azure Web UI that we have 3 master nodes and 3 worker nodes. As I said, the master and worker nodes are a standard instance. They have no additional confidentiality and there is nothing special. They are standard VMs. The first thing that I installed on my cluster was the OpenShift Sandbox Containers operator, which provides this PeerPods technology, and the Red Hat OpenShift Data Science operator, which provides all the AI infrastructure. We can look inside the Sandbox Containers operator, and we can see that we have PeerPods enabled and up and running. Let's look at the workload. The workload is provided by KaiKit, which is also provided by the Red Hat Data Science operator, and it's running an LLM. This workload without confidential VM, as I said, it will run on a pod on a worker node, and the data could be available to the host. The cloud provider could, for example, access this data. Using confidential VM, we add an additional layer of security, and there's no way to access this data. Okay. Let's, in order to run this pod as a confidential VM, we first need to extend the runtime class to run the Kata runtime. So I already went ahead, and we can see that this pod is called FFF547, and we can see inside the PeerPods logs that this pod FFF547 was created as a PeerPod object. An instance was created, so a VM was created called deployment FB3C, and the instance type is the DC. So you can see that there is this additional C in the naming. This is provided by Azure naming, and C stands for confidential. We can indeed see in the Azure Web UI, for example, that this FB3C instance is present as a separate VM and is running this DC instance type, which is a confidential VM. For this demo, we are using a TDX image, so this DC Azure image also we can see via the EDS naming that supports the TDX technology. We can also check that by checking inside the pod. If we run the message and we grep for Hyper-V, we can see that the only way at this moment to check for if TDX is enabled is to look at this line, and you can see that by matching these numbers, TDX technology is up and running. Okay, let's go back to the AI workload. And we can see the next step is that now that it's running in a confidential VM, we can look at how to encrypt and decrypt the model inside the confidential VM. We don't want the model to be shipped as plain text available to anyone, but we want to ship it as encrypted, and then the confidential VM should be able to decrypt it and run it. So in order to do that, I will go a little bit in the technicality. I will show you how the model is deployed and used by KiteKit. So the deployment is made available via this min.io Docker, so this container, and we extended that in order to add this fence program, which is used for encryption and decryption. And basically this program, this pod essentially just downloads a key. This is public key that I made public available, because this is the step that should be done securely in another environment by the data scientist. So for the purpose of this demo, we modified this container to take the key, encrypt the model, and remove the key, and remove also the plain text model. So there is no key and no model, plain text model inside the demo. There will be only a PyTorch model.bin.enc. I will show you later in the logs. Then the first thing that the KiteKit confidential VM does is to download the keys from using a separate process, is not downloaded publicly, and then it will install, will decrypt the model, and will use it as it just a normal binary for run the AI. So we modified the initialize entry point here, and we can see that here we download the key. The key is loading using the key broker service. The confidential containers key broker service is a remote server which facilitates remote attestation, which what basically means is that this server is not providing the key if the VM is not, unless the VM is a confidential VM and it has been successfully attested. Once we get the key and the attestation is passed, we can just decrypt the file just with the same fence program, and then we rename it to PyTorch model as it was before, so that the whole execution can continue. And I can show you here inside the logs of the storage initializer that initially we have the PyTorch model encrypted. There is nothing else here. Then we download the key, the decryption is successful, and then we see the encrypted model and then the decrypted model. And then we just rename the model to have the PyTorch bin. After this, the model is up and running and it's available to the end user. So we can see here that is available. And to conclude, we can use this script to connect to the model and send gRPC requests. So we connected to this FFF pod for the K-server demo, and then we can ask him ciao, and he will answer. And we can ask what time is it, and he will answer. This concludes my demo. Thanks a lot, and goodbye.